Hey guys, this is video 2.10. We are going to talk about orbital notation now, which piggybacks on our last video, which is 2.9. So we're going to start by writing out noble gas notations, and then we're going to draw either circles or squares to represent the orbitals to where the electrons are located. Okay, so when we take a look here at vanadium, so I'm going to kind of scroll back up to where I was in the last video, clean it up a little bit. If we look for vanadium, right, which is right here, write your noble gas notation down. That's the first place to start when you're asked for orbital notation. So up and over, argon is going to be our noble gas of reference, and then we're going to write 4s2, 3d3 would get us to vanadium. Okay, so nothing brand new here. The new part now comes with orbitals. So this is where remembering SPDIF, right? S, P, D, F, and then the pattern that corresponds to it. 1, 3, 5, 7 that we talked about in an earlier video. Okay, these are representative of how many orbitals or bunks that each sublevel has, each room has, if you think back to your boarding house analogy. So the S has got one orbital. Now how many electrons go in there? Okay, there's going to be 2. So we represent those with arrows, okay? One up, one down. Remember, because Pauli's exclusion principle means that they can't have the same spin, so one is going to be up, one is going to be down. You can write full arrows, guys, if you want. You will see me abbreviate with half arrows just because it's a little bit easier when you write a lot of them out. Now, the D block has got 5 orbitals or bunks in it where electrons can be found, so we're going to write them all out. Now, when we start filling them in, you might be asking yourself, why did I spread them out? Why did I not just double them up, with that space? So what's the difference, do you think? The difference is energy, guys. Remember, atoms are lazy. They want to use the least amount of energy possible, so they will spread out. Think about it this way. The analogy that I use is, okay, if you have to sit next to somebody like on a train or a plane, right, and you've got a seat, two people in each row, would you rather, if somebody's sitting in a seat in that row already, would you rather go to a new row and sit by yourself, or would you rather sit next to that person? Complete stranger, okay? Most people are going to go to a different row and spread out, okay? Electrons do the same thing because, remember, they want to repel each other. They have the same charge, so they want to get away. This is known as Hund's rule, which is listed right below. They fill in empty orbitals first before they start pairing up, okay? So remember, when you're drawing it in the next video when we talk about Lewis diagrams, we want to spread them out first before we do that. The S always fills first, then all the other ones come next, and we spread those out. So arsenic, let's go ahead and do that as well. Go back up to our periodic table. Let's find where arsenic is. It's right here. So we're going to use argon again as our noble gas, and then we're going to write it out. It's going to be 4s2, 3d10, 4p3. So we have more boxes to draw, but again, break it down. SPDIF, 1, 3, 5, 7. So S has got 1. I'm going to fill in its electrons. D is the big one that has 5. Okay. Now there's 10, so fill them all in first. 4, 5. Then start doubling up. It doesn't matter, guys, which ones you put them in. So over here, okay, just as a side note, I could have went like this if I wanted to. It doesn't really matter as long as you fill in all of them with 1 first, then start doubling up. So if you double up, it doesn't matter which one you double up first, okay? Just keep that in mind. And then P has got 3, so there's going to be 1 electron in each box because it spreads out according to Hund's rule. All right, so what I would encourage you guys to do, not much different than our last video. It's more practice with the noble gas notation. Now it's just, drawing in that last piece. So pause the video, excuse me, and then you guys try the orbital notation for these following ones. So selenium, you to get argon, it would be 4s2, 3d10. Let me rewrite that. 4p4. So if you did not get that, go back and check and see why. So the S is going to fill in like that. We're going to have 5 orbitals for the D. They're all going to be filled in. I know I didn't just, spread them out first, but I knew they were going to be filled in. So So for the sake of time right now, but always spread them out first, like I'm doing with the P. It doesn't matter which P you put it in. Okay? Nickel, argon as well, 4s2, 3d8. So again, start with your S first, then fill them all in. 1, 2, 3, 4, 5, 6, 7, 8. Again, you could have started with the left, guys, doubling up. That's fine. It doesn't matter where, as long as each one has one first. Chlorine is going to be neon, 3s2, 3p5. So start with my S. Those are filled up. My P, 1, 2, 3, 4, 5. I could do it like that if I wanted to. And then sodium, Ne3s1. Pretty easy. You could also start down. It doesn't matter, guys, if you start up or down, as long as they are opposite spins. Okay? So there's extra practice. Ask questions if you have it, and I'll see you in the next video.